Welcome to the numerical analysis course. In last lecture we started studying Gaussian elimination method, and in this lecture we'll continue with it with another example where we'll solve a system of linear equations. There are 4 such equations. We'll solve them simultaneously using this method Gaussian elimination, and the method is implemented using these 3 steps we studied last time. Step number 1 is that given a system of linear equations, we convert it into an augmented matrix. This one, like this. This is augmented matrix. We'll study it further. Using row operations, we reduce to a triangular matrix where we have zeros at certain places in the form of a triangle in our resultant augmented matrix. And once we are done, we perform step number 3, that is, we revert back to the equations form and find the unknowns quite easily as compared to this system of equations, the point we start with, right? So in this, given this system of linear equations, there are 4 such equations. We obtain an augmented matrix using these 4 equations. We put the coefficients in the form of matrix, and after this column we put the number that is on the right hand side of the equation, and we do that for all the 4 equations given in the problem. Right. Having done that, we'll go to step number 2, where we perform some row operations. The first, actually, we are going to find, or we want to find a triangle of zeros, right? We want to form some row operations unless we get a triangle of 0, and the triangle should be like this. We want a 0 here, and a 0 here, a 0 here, a 0, a 0, and a 0. So we want these. How many are they? 1, 2, 3, 4, 5, 6 numbers to be 0. And once we have done that, we will be in a very good position to perform step number 3. We'll revert back to the equation and we'll find the unknowns quite easily. So this is step number 2, where in search we are going to find this augmented matrix, or you have to convert this augmented matrix in the form that we have zeros at these 6 places, right? For that, we'll apply some row operations repeatedly. Right, we'll start with making this 0. So how to make this 2 equal to 0? For that, we'll perform this step. E2 is 2 times E1, or R2 is R2 minus 2 R1. Row 2 is, the new value of row 2 will be the old value of row 2 minus 2 times the value of row 1. This means row 1, row 3, and row 4 will be as such, they won't be changed. So I have copied these 3 rows, row number 1, row number 3, and row number 4 from this matrix, and I'm going to write this row number 2 as E2 minus 2 times E1, or R2 is R2 minus 2 times R1. So R2, the new value of R2 would be R2 minus 2 times R1. So what is E2? 2 minus 2 times this R1. 2 minus 2 is a 0, so we get a 0 here. So minus 2 times minus 1, minus 2 minus 2 times minus 1. 2 times minus 1 is minus 2. So this is minus 2 plus 2. This is 0 as well. So E2 minus 2 times E1, 3 minus 2 times 2, 3 minus 4 is minus 1, this one. And E2 minus 3 minus 2 times E2 is minus 2. So this is minus 3 plus 2, it's minus 1. And E2 minus 20 minus 2 times E1, minus into minus 16. So this is minus 2 plus 16 is minus 4. So this is how we do that. And as a result of this operation, we have obtained a 0 at one of our 6 desired places, this one. So now we have a 0 here. And then we have to perform some other row operations unless we have these 5 elements equal to 0. Right. For that, let's make this equal to 0. For that, we will have E3 as E3 minus E1, because E3 minus E1, 1 minus 1 is a 0. So we'll write row number 1, row number 2 and row number 4 as such. This row 1, this row 2 and this row 4, and row number 3 of course will be changed. I have written it with another color, the blue color. Right, so E3 minus E1, 1 minus 1 is a 0. E3 minus E1, 1 minus into minus 1, it's 2. E3 minus E1, 1 minus 2 is minus 1. E3 minus E1, 0 minus into minus 1 is plus 1, and minus 2 minus into minus 8, minus 2 plus 8, 8 minus 2 is 6. Right. Now we have obtained a 0 here and a 0 here, but we want a 0 here, a 0 here, a 0 here and a 0 here to complete step number 2, and then we will be going to step number 3. Right, so for that we'll apply E4 to bring a 0 here. To bring a 0 here, we'll apply E4 minus E1. E4 is E4 minus E1. That will bring a 0 here. So first let's bring a 0 here. E4 is E4 minus E1. So we are going to change E4. This means 1, 2 and 3. Row number 1, 2 and 3 will remain as such. So I'll take a while to write these 3 rows. Minus 8. Oh, 2 is 0, 0. Minus 1, minus 1, minus 4, and row number 3 is 0, 2, minus 1, 1, and 6. And now row number 4 is row number 4 minus row number 1. So it's 1 minus 1, so 0. And then minus 1 into minus, minus 1 plus 1, it's a 0. And then E4 minus E1, 4 minus 2 is 2. And E4 minus E1, 3 minus into minus 1, 3 plus 1, 4. And then E4 minus E1, 4 minus into minus 8, 4 plus 8. This means it's 12. Now I have this matrix and I want to have zeros at these 6 places. Now I have a 0 here, a 0 here, a 0, a 0. One important trick that we can apply here is we can replace row number 2 and row number 3 to make it more closer to what we desire. So if we replace row 2 and row 3, we will be more closer to our desired matrix. Right, so this means row number 1 and row number 4 will be as such. 0, 0, 2, 4, 12. And now we are going to replace row number 2 and 3. Write row number 3 first. 0, 2, minus 1, 1, 6. And then row number 2, 0, 0, minus 1. It doesn't make any difference. Either we write row number 2 first or row number 3 first. Right, so 0, 2, minus 1, 1, minus 1, 1, 6, right? And row number 2 is 0, 0, minus 1, minus 4. Right, now we have 0 here, 2 zeros here, and 2 zeros here. We are very close to what we desire. And the last thing is that we want to have a 0 here. Right, so for that, let me cheat a bit. We'll perform E4 as E4 plus 2 E3. E4 as E4 plus 2 E3. Alright, this means we are going to have the same first 3 rows, but the last row would be E4 plus the 4th row plus 2 times the 3rd row. So this means the 4th row, this means the 4th row, or should I write it here? Oh, I have a space here. Alright, so let's write the result here. E4 e4 plus 2 e3. This means the first three rows are the same. 1 minus 2 2 minus 1 minus 8, and 0 2 minus 1 1 6 0 0 minus 1 minus 1 minus 4, and the last row is e4 plus 2 e3. 0 plus 2 times this is 0. 0 plus 2 times 0 is a 0. 2 plus 2 times minus 1 minus 2. 2 minus 2 is a 0. 4 plus 2 times 4 plus 2 times minus 1 minus 2. 4 minus 2. 4 minus 2 is a 2. And then 12 plus 2 times minus 4 is 12 minus 4 2s are 8. 12 minus 8 is 4. So this is our final augmented matrix. After the required number of row operations, we have obtained zeros at 6 desired places, and now we are ready to perform step number 3, that is, we'll revert back to the equation form, and then we'll find ourselves in a very good position. We'll find ourselves in a very good position to find all unknowns x1, x2, x3 and x4. Right. So let's perform step number 3 and revert back to the equation form. x1 minus x2 plus 2x3 minus x4 is minus 8. Equation number 1. Equation number 2 is 0x1 2x2 minus x3 plus x4 is a 6. The third equation is minus x3 minus x4 is minus 4, and the last equation is 2x4 is equal to 4. So now we can straightaway find x4. 2x4 is 4. This means x4 is 4 by 2. It's 2. And now we can put the value of x4 here in this equation to find x3. Minus x3 minus 2 is minus 4. This means x3 is, taking x3 on the other side of the equation, minus 2, taking 4 here, becomes plus 4. So x3 is also 2. So x4 is 2, x3 is 2. Let me check. Okay. And then we can put the values of x3 and x4 in this equation to find x2. x3 is 2. x4 is also 2. So this is 2 minus 2. So 2x2 is 6. This means x2 is 6 over 2. It's 3. And finally, we can plug all these values in here in this first equation to find the unknown x1. x4 is 2. Let's replace this with 2. x3 is 3. We put 3 times 2, 3 2s are 6. And x2. Oh. That's a small mistake. This was 2x3. x3 is 2. So 2 times 2 is a 4 plus 4 minus x2 is a 3 minus 3. Right. So now we have 4 minus 2, 2. 2 minus 3 is minus 1. So x1 minus 1 is minus 8. This means x1 is minus 8 plus 1. This is minus 7. So x1 is minus 7. Right. So now we have computed all 4 unknowns, x1, x2, x3 and x4, and we can optionally verify the answer we have reached to. Right. Let's check it. Let's verify our answer. Verification. It's very simple, straightforward. Put the values, plug all the values x1, x2, x3, x4 in all these 4 equations, and you will find on the left hand side of these equations, and you will find the answer that we have on the right hand side. For example, let's put these values in the first equation. x1 is minus 7 minus x2 is minus 3 plus 2 times x3. x3 is 2, so 2 times 2 is a 4 minus x4 is a 2. Let's see what we reach to. Minus 7 minus 3 is minus 10, minus 10 minus 2 is minus 12, plus 4. Minus 12 plus 4 is minus 8. This is the same as right hand side of the first equation. This means it satisfies equation number 1, the first equation. Right, we can check equation number 2, 3 and 4. For example, let's check equation number 3, x1 plus x2 plus x3. It seems simple. Minus 7 plus x2, x2 is 3 plus x3 is 2. Right, 3 plus 2 is 5, minus 7 is minus 2, and minus 2 is the right hand side of equation number 3. The remaining 2 equations you can verify these 2 equations yourself. I am gonna leave it as your homework. You'll see if you put these values on the left hand side of these equations, you will get the thing that you already have on the right hand side. Right, that's all for this lecture. We'll continue studying more about system of linear equations using numerical methods in our upcoming lectures. Thank you.